Okay, this is just a short video reviewing some of the work we're doing with trig identities. When using trig identities, it's important to know some foundational, fundamental identities, which I've listed here. We have our reciprocal identities. So sine is the same as 1 over cosecant, cosine is the same as 1 over secant, tangent is the same as 1 over cotangent. We also have our quotient identities. Tangent is the same as sine over cosine, and then we have our Pythagorean identities. So there are three different forms of the Pythagorean identities. Using just these three categories of fundamental identities, let's try rewriting some expressions. So what we're going to do here is try to make the 5 expressions on the left match to something on the right. Not necessarily the easiest task, but all we're going to use are those fundamental identities we just looked at. Let's start with the first one. So when we see a tangent of x, if we go back to our identities, tangent can be expressed as 1 over cotangent from a reciprocal identity, or we could express it as sine over cosine from a quotient identity. Let's go ahead and try the quotient identity. It's often helpful to rewrite everything in terms of sine and cosine. So we're going to go ahead and say that tangent is the same as sine over cosine. And we'll keep everything else in this expression the same for the moment. So we can see just by rewriting tangent in that way, we now can cancel out a cosine term. So this is truly just equal to negative sine of x. When we look at the right-hand column, we don't see a negative sine of x, but we do see a sine of negative x. And using our negative angle identities, basically our knowledge of sine as an odd function, sine of negative x is the same as negative sine of x. So 1 on the left matches with c on the right. Let's try the next one. So the second one we're given here says secant squared of x minus 1. If we come back to our Pythagorean identities and look for a secant squared term, I'm going to focus on this middle identity. If I take this middle identity and subtract 1 from both sides, it's still true, and that would say that tangent squared of theta is equal to secant squared of theta minus 1. So again, all we did to this middle identity was subtract 1 from both sides. What this means is that in the problem we were just working on, when I see a secant squared of theta minus 1, I can fully replace that by tangent squared. So I see the secant squared of x minus 1, I'll replace it fully by tangent squared. And again, I look in my right-hand column, I don't see a tangent squared function, but if I investigate a little further, this first choice says sine squared over cosine squared. And that really means sine of x over cosine of x quantity squared. And we know that sine over cosine is just tangent. So squaring the tangent function can be written tangent squared x. This means 2 on the left-hand side matches with option A on the right-hand side. The next one, we're given secant divided by cosecant. And for this one, I think we're going to appeal to our reciprocal identities. So I know that secant is the same as 1 over cosine, and cosecant is the same as 1 over sine. So again, I really have to have a working knowledge of these fundamental identities on this page for the process we're working through to even be possible. So we just said that secant is the same as 1 over cosine, and cosecant is the same as 1 over sine. I have a fraction divided by a fraction, which is the same as multiplying by the reciprocal. So this is the same as 1 over cosine multiplied by sine over 1, which can be written as just sine over cosine. And looking at the right-hand column, I don't see a sine over cosine, but I do see a tangent. And tangent via the quotient identity is the same as sine over cosine. Therefore, 3 on the left must match with E on the right. I'm going to skip over number 4 for just a brief moment and explain that one after we talk about number 5. Number 5 has cosine squared. There are many ways to rewrite cosine squared, so at this point I'm going to start using a little bit of process of elimination and look at the right hand side to decide what to do. On the right hand side, for b, I see 1 over secant squared. So we know that 1 over secant is actually the same as cosine via a reciprocal identity, and it's just being squared. So it turns out that cosine squared of x is just the same as 1 over secant squared of x. So 5 and b must match. Now you may be saying it's obvious now that 4 and d are correct, and it's true, but let's make sure we understand why. For this one, I feel like it's easier to actually begin on the right-hand side, looking at d, to work our way backwards to 4, which says 1 plus sine squared of x. Let's look at our Pythagorean identities one more time, focusing in particular on the identity involving cosecant and cotangent. So if I look at this third Pythagorean identity, I notice that if I were to subtract cotangent from both sides, we would arrive at 1 is equal to cosecant squared minus cotangent squared. That means that anytime I see cosecant squared minus cotangent squared, I can replace it by 1. Cosecant squared minus cotangent squared is exactly what we have here on D. Therefore, that whole piece can be replaced by 1. We'll just drop down the adding sine squared of x term that we already saw. And now 4 and D are a match. So using this process is a bit frustrating at first until you really have these fundamental identities down. So I can't stress enough how important it is to spend time getting familiar with them. So feel free to use the Quizlet flashcards I've put on Canvas. That's one great resource. Write them out for yourself, put them in some sort of visual representation, do something to process these different identities, and then this process of rewriting will become a bit more tangible. So hopefully that helps.